Welcome to the Edmonton Python user group. We're in a channel called Meetup EdmontonPy. So what the Edmonton Dev Society is, it's a group of meetups, and they provide us with this hardware here so that we can record our talks, and also they provide us with a little bit more framework for running a meetup like this, taking donations and stuff like that, and as well as taking money for sponsorships. So if you're not on the Slack, please join the Slack. So thank you for the Organic Box for sponsoring today's meetup. They'll be paying for the pizza today and all of that stuff, so thanks. If you're interested in sponsoring the Edmonton Python Meetup, let me know and we'll get in touch. Thank you to Startup Edmonton for providing us with this space. So without Startup Edmonton, we would have to go and find someone's creepy basement and we all wouldn't fit. So thank you. When you're talking to each other in a group, we would like you all to remember the Pac-Man rule. So just try and leave an open space so that someone can come join your conversation. That's about it. So it's more open and inviting for everyone to just join in and start talking. The talks today will be with Eddie, and he'll be talking about demystifying CPython Bytecode. So very cool stuff. And I'll be talking about image to text. So taking an image, converting it to text. I have to write my presentation, so I'll be doing that while Eddie's presenting. So there's a few events coming up. DjangoCon, which is in September, and PyCon Canada, which is in November. If you're going to PyCon, let us know and we'll try and meet you there, see you, hang out. So, Django security. So there's a security update released. So if you're using Django, please update. There's two jobs that we have told to us. There's Leventon, which is an electronics company. They build kind of like light switches, but they're all wireless, so they don't take power. They usually do it in new houses that haven't had any power ran yet. So yeah, smart light switch, no power ran to it. The electrician just slaps in a gang box and then puts in a Leventon switch. It's all wireless. It uses a watch coin cell battery in order to work. The battery lasts for 10 to 15 years. So yeah, it's a really cool opportunity, really cool job. The head developer there, I know him personally. He is the best programmer that I've ever met. So if you are interested in learning a lot, it's a great opportunity. They're looking for something a little bit more DevOps related rather than just pure Python, but they use Python and Go. So, and then there's also another job opportunity with Helm, and I'll let Aaron speak about that.
Yeah, so this one, we're looking for a senior backend developer. A little bit of a DevOps lean to it as well, only because we are a startup. We are a very small organization of 4 people, including me so far. We have a Django backend stack, and there is quite a bit to do on the backlog. And so I'm looking for someone who's ready to write testable, maintainable code in a startup that doesn't quite operate like a startup. We try to make sure that our people do not work more than 35 hours a week. Something I'm trying to keep maintaining, even though the backlog keeps exploding in size. But if you'd like to join a startup that doesn't quite operate like a startup, come talk to me in between the talks or after the talks. I've also got a couple stickers as well, so if you just want to come chat up with me, I can, give you a sticker as sort of a sign of thanks. And yeah, come talk to me if you're interested. Thanks.
Thanks. If you do have jobs that you would like posted here, just reach out to me. I'm DataGet on Slack, so you can just message me directly or just come up to me. It's fine. I don't bite. Yeah. There's a few interesting articles that I didn't read, but I just put it on this list because I did it a few hours ago. So inheritance, which is pretty cool in Python, so classes and inheriting. 11 beginner tips for learning Python, which aren't actually like about coding. It's more about like taking a break and like relaxing and stuff like that, right? Why your mock doesn't work, which is a cool little blog post about how mocks work and why mocking individual instances doesn't work for a full class. Memory management in Python, which is interesting. I wish I read it. I didn't. How to make a scatter plot in Python using Seaborn, which is just really neat because you can get that data and visualizing it, you can see, a little bit more what's going on with the data a little bit better. And then Alive Progress, which is a library used for making a progress bar in Python. So if you have a console and you want to display a progress bar, it makes a really fancy one with minimal amounts of code. Python tip is PDB. So if you don't know, Python has a debugger built into the language. So you can just run the top line of code, which is import PDB, and then semicolon to say it's a new line, and then pdb.setTrace. And what that will do is when Python is executing and it runs into this line, it will stop and drop you into a REPL. So then you can go and start typing, and it's just like you're interacting with Python right then and there. So it's really cool because you can output variables, you can start running functions, doing things, and it's stepping through the code and debugging it at the same time, right? So if you hit the C button and you hit enter, then it continues to execute your application, so you get out of your PDB. If you hit N, it steps to the next line and runs the line of code. LL prints out the entire function that you're in, and L just prints out the current line that you're looking at, and then when you're to print L again, it just continues off after that. So the next meetup is September 9th. Yeah. So Eddie's going to be talking, so if you can all give Eddie a big round of applause.
Hello! So, my name is Eddie, and I'm going to be demystifying CPython bytecode, or what are those PyC files anyway? So, what am I talking about? Has anybody here, ran their Python code and looked inside the folder and saw right beside your beautiful Python module a file that has the same name, but with the extension .pyc? Raise your hand if you've seen that. OK, a few people. How about, same thing, you run your module, but suddenly a folder called PyCache appears. Have you seen that? Raise your hand. Excellent. And if you've peered inside the PyCache folder, you'll find there's a PyC file in there. So the topic of today's presentation is, what is this thing? Why is it created? What does it do? And we're actually going to go inside it and see what it's all about. So once again, in today's talk, what is a PyC file? What is CPython bytecode? How can I view this CPython bytecode? And then we're going to step through it, and we'll understand what that means later. And maybe if depending on where'd he go? If he needs more time writing his presentation, we might write a CPython bytecode interpreter. Maybe, maybe not. OK, what this talk is not about is, so has anybody here used PyPy or Jython or IronPython? Hands up. OK, just a few people. I'm not talking about any of that. So just get it out of your brain right now. For the rest of you, these are alternative Python implementations. You still write the same code, it's run in a different way. I'm just talking about the vanilla Python program that you download from the internet or is already installed on your computer. Just the plain basic Python. That's what I'm going to be talking about today. So, what is Python? Well, you see, Python is an interpreted programming language. Wikipedia says so, and Wikipedia is never wrong. Remember that. But for real, let's dig into this word called interpreted, right? So some people make a distinction between interpreted programming languages and compiled programming languages, right? An interpreted programming language is one where you have your source code, you put it in a program, and then it runs instantly. It just happens. You just have the code, and then suddenly it starts running. Voila. There's no thing you have to do to explicitly translate it into whatever. It just runs on the fly. So that would be programming languages such as JavaScript, Ruby, PHP, and many other of those so-called scripting languages. That will contrast with compiled programming languages. So these are things like C, C++, Rust, Go. These languages, you have to, before you can even run your code, translate it into a form that's more runnable by your computer. There is a step that you have to do. You have to go out of your way to translate your code into a simpler form that your computer can understand. This is what it means to be compiled, right? Is anybody going to disagree with me on that point? OK. But listen, Python, we know, is an interpreted language. If that's the case, then how come if I go into Python source code, I find a file called compile.c? What is this? What's going on here? All right. So Python, or rather CPython, does not actually understand Python code. It doesn't understand Python source code directly. What? So if Python doesn't actually understand Python source code directly, what does it understand? So as I mentioned, C, C++, Go, Rust, all those other programming languages, you have to explicitly translate them. They usually get translated into machine code, which your computer processor, your CPU, understands automatically. Python is a little bit different. CPython, there is a compiler. It's called compile.c, but it doesn't go into instructions your CPU understands. It goes into something called bytecode, CPython bytecode. That's what we're going to talk about. So CPython understands bytecode. That means that Python, the program that you run on your terminal or wherever you run Python, actually is responsible for two separate things. Number one, it reads in the Python source code that you wrote, and it compiles it into this CPython bytecode and some data. That code and that data bundled together is called a code object. Second, the CPython executable, that program you ran, takes that code object and interprets it. And we're going to understand what interpretation means later. So for those of you who know what interpreters are like, Python is a stack-based virtual machine. But I'll explain later what that means. So then, what actually is in a PyC file? PyC files, they just contain that compiled CPython bytecode and that data, the code object that I was mentioning before. Why, though? What's the point of having a PyC file? Well, it turns out that that compile.c I was showing you before is like 6 billion lines long and is super complicated, and it is super slow, relatively. Do you know what's faster than compiling source code? Not compiling any source code at all. So when you import a module or a library, like say you were to import Django, and Django is made up of a bunch of different smaller py files, .py files. When you actually do that import, Python goes and compiles that entire library, right? The very first time you import the library. So it'll probably have like hundreds of Python files. It will compile them as it goes. The next time you run your program that uses that library, it's already compiled that library. It doesn't need to go and read the source code again. It's already done. So the PyC caches the code object. That way you don't have to compile it ever again. So yeah. Then what is the point of this PyCache folder? So for anybody who's used like Python 2 or a version of Python 3 before 3.2, when you'd run your code and has a whole bunch of modules, you'd see, OK, I have a .py file, and right beside it, suddenly there's a .pyc file, and maybe there's a .pyo file. And that would happen for all of your modules, right? It made things really cluttered. Sometimes you wanted to just delete all the pyc files, so you'd have to like go in and like rm star.pyc or something like that. Maybe you typo it and do rm star.py. Bad, right? Instead, after Python 3.2, they introduced the PyCache file. And literally all they did is took all those pyc files. Now they're in PyCache. There's also a little tag in the file name so that you can actually share one PyCache files with multiple different Python interpreters. So a whole bunch of different versions of Python can coexist on your system and make use of the same folder. OK, so with that out of the way, let's actually look inside a pyc file. So for now until the end of this talk, I'm going to be focusing on this function, right? It's called greetings.py. It's a single function called greet. Can somebody tell me what this function does? Excellent. It prints out hello world. And it makes use of, how many variables do I make use of? Two? Three. Yes. So I have 3 variables. It prints out hello world. We are going to see how Python actually interprets this. So to actually create the pyc file, like I said, it happens automatically whenever you import a module. So here I'm just saying from greetings, that's my file, import greet. So then I get my function called greet. And as you can see, when you run it, it just says hello world. If I get out of my Python interpreter and look at the files that it's created, you'll see it's created a PyCache folder. And inside that PyCache folder is greetings.cpython 3.7.pyc. So the pyc file has been created. That source code has been compiled. Bytecode is in that pyc file. So how can you view the bytecode? Well, you can just get your favorite hex dump utility and put the pyc file, and voila, there's your bytecode. The end. OK, see y'all. OK, obviously, we're not just going to leave it at that. Let's actually try to look at the bytecode in a more understandable form. So there's this nifty module in Python. It's built in. It's called dis, D-I-S, which stands for disassemble. So the way you use it, just start up Python, import your module, import the function you want to look at, import the dis module, and then dis.dis of the function whose bytecode you want to see. Once you've done this, it will print out all of this stuff. So my little function here is internally represented by this bytecode. So OK, that might be confusing to just show you all that stuff, but I'm going to explain it. And we're going to go through it line by line. To get that, I did import dis.dis of the function. And that works for any function you give it. So yeah, it prints out that stuff. That stuff's confusing. Let's make it less confusing. So what is the C Python interpreter actually doing? Well, it takes those code objects I was talking about before, which is a list of instructions, which is encoded as a byte string, hence bytecode, and alongside the other supporting data, and I'll explain what supporting data it uses, it interprets each bytecode instruction one at a time. Each instruction is made up of 2 bytes, an opcode followed by an argument. And whenever there are intermediate values, they'll be stored in the value stack, and we'll see that later. So to just kind of show you this big dump of bytecode again, all of this stuff on the left-hand side, those are the instructions. All the stuff on the right-hand side, those are the arguments. The dis.dis module also prints out the program counter, is what I'm going to call it, and also the source code line number. So those numbers at the very left actually correspond to the line numbers in your source code. OK. So maybe this still isn't clear. Let's actually go through this program one instruction at a time. Let's interpret the bytecode. So our first instruction, which corresponds to greeting equals hello, is load const with an argument of 1. So all of these things, the hello world and the space as a string, those are the constants in your function. Quick question. If I have a function that doesn't have a return statement, what is its return value? None, right. So secretly, Python inserts a line that says return none at the bottom. So not only do we have all those strings as constants, we also have none as a constant. So to go back to that code object and its supporting data, it has something called code object constants, or CO consts. And that's just a tuple. In this case, we have a tuple of 4 values, which are all the constants we use in the function. So none, hello, world, and a space. Load const of 1. Actually, I'm getting ahead of myself. So where do those constants get loaded? What does it mean by load const of 1? Well, there's this thing called the value stack. Who here is familiar with a stack data structure, computing science? All right, OK. So there's only 2 operations we're going to talk about here with a stack data structure. And so what happens here is that load const 1 will look inside our const tuple. It'll go to the 1th value, so 0 and then 1. So what's at the 1th value in my const array? Hello, right? And what it's going to do is it's just going to pop that onto the stack. It's just going to get added to the end of the stack. Or sorry, push, thank you. All right, cool. Our next step is we're going to store a variable, right? Our source code says greetings equals hello, so something is going to go into the variable greeting. And that's done by this store fast instruction. So store fast of 0 means we have an array of, we have a list of local variables. In our function, we have 3 total local variables, so Python pre-allocates a list of 3 variables. So store fast says pop whatever's in the value stack and put it into local variables at index 0. Are you with me so far? OK. We're going to do this one more time. Because the next line, recipient equals hello, or sorry, recipient equals world, that's the same thing. We're going to load const at 2. What's CO const at index 2? World. Excellent. So we're going to push that onto the stack. Then we go to the next instruction, which is store fast. So pop what's on the value stack and store it into index 1 of the local variables. So we pop it, and it goes into the local variables. And there we go. We ran the first 2 lines of code, which translate into 4 bytecode instructions. Phew. All right. It's going to get a little bit more complicated in the next round. So now we go on to this sentence equals greeting plus space plus recipient. So number 1, we do this load fast. So just like store fast assigned to a local variable, it put a value into our local variables list. what do you think load fast is going to do? It's going to take a local variable and place it onto the stack. So load fast of index 0 is going to look into our local variables. What's the first local variable we have? What's stored there? Hello. So it's going to take hello and it's going to push it onto the stack. The next thing we're going to do is load const at index 3. What do we have at index 3 of our constants? The space. So the space is now going to be pushed onto the stack. Excellent. OK, so now we get into exciting stuff. The next operation is binary add. Binary add, it's just going to be the concatenation, right? So we're going to pop the, I'm going to call it the right-hand value from the stack, and it's going to pop the left-hand value from the stack. And then it's just going to look at those two values and try to add them together. In this case, it means string concatenation. So it's going to do the string concatenation, so hello space. And then that result is going to be pushed onto the value stack. Excellent. OK, so are we done with this line of code?
No.
No. OK, we still have a little bit more left to do. So let's move on. So our value stack has hello space in it, right? So the next thing we're going to do is we're going to load fast from index 1. So we're going to look inside our local variables at index 1. What's in local variables at index 1? World. So it's going to load world, push it onto the value stack. And who can guess what the next instruction is? Binary add. Excellent. Yeah. So binary add, just as before, pop, pop, adds those two values together and pushes hello world onto the value stack as one string. So the next thing is it's going to store fast into index 2. So look at local variables. That last index that is currently unbound is where sentence is. So store fast is going to pop that and place it into local variables at index 2. Excellent. So now we print the result. So here I've introduced a new instruction, load global. Load global 0. Why am I loading global as opposed to loading fast? That's correct. So print is technically a global variable. Well, technically it's a built-in variable. So print does not live inside your function's values. It lives inside this thing called a built-ins namespace. Has anybody here heard of the built-ins namespace? OK. So there are 3 different places where Python can find a variable. One is locals, and we've been dealing with locals so far this entire time. Those are just to one particular function. And then you have your globals. That's whatever is in your module. So if you have a brand new Python file and say hello equals whatever, that's going to be a global variable. And then finally, the built-ins namespace contains all of those functions and those classes that exist in Python without you having to import anything. So things like int, float, dict, tuple, or functions like property. I don't know. Basically anything that you didn't have to import to get into Python, that's going to be in the built-ins namespace. All of those things are built in. And one of the things that is built in is the print function. So load global of 0 uses actually this CO names attribute of the code object. So in addition to storing all the constants, your code object also stores a bunch of names as strings to global variables. So what Python has to do in order to do a load global of 0, it looks inside CO names at index 0, finds print, and then there is a dictionary called built-ins, and then it will have to do like a dictionary access of that built-ins namespace to find the print function, right? So this is a lot more, this is another level of indirection compared to loading a local variable, which is why loading a local variable is called load fast versus loading a global is just load global. So once it's found print inside the built-ins namespace, it will push that onto the value stack. Now we load the argument to print. Load fast at local variable 2. So what do we have in local variable at position 2? I feel like I've lost people here. yeah. OK. So local variables. We have at position 0, hello at position 1, world at position 2, hello world. So load fast at position 2 will push hello world into the value stack. So the next instruction is call function. And its argument is how many, its argument is how many arguments the print function has. So we're going to pop all of its arguments. There's just one. We've prepared all the arguments for the print function. Then we pop the function itself, and then Python will actually execute it. So what ends up happening is that on our screen, we see hello world. At this point, we finally see hello world on our screen. Cool. Can anybody tell me what the return value is of print? None. OK, good. That's kind of a trick question. But yeah, print doesn't have a meaningful return value, but everything in Python has to have a return value. So it just returns none. So what call function also does is whatever that function returned, it doesn't care what it is. It's going to push that onto the stack. So none gets pushed onto the value stack. All righty. But if we look at our line, print sentence, nothing is done with the return value of print. So Python just throws it out. And that's what the pop top instruction does. It just pops the value stack and just throws it out. It doesn't get stored anywhere. Excellent. Finally, the return statement. So we're in the final stretch. There are only 2 more instructions left. Once again, even though we never wrote return none, Python secretly is like, oh yeah, this function totally returns none. What are you talking about? So load const at 0. What's the 0th element in our constant array? None. Right. So it gets pushed onto the value stack. And then return value. This will pop whatever is on the value stack. And that finally gets returned to whatever called our greet function. And there we go. We did it. We interpreted this Python function 1 bytecode instruction at a time. Way to go. Andrew, do you need more time? Stall. OK. OK. So this is going to be really, really fun. What we're going to do now, give me a second. All right. I'm only somewhat prepared to do this. All right. So, OK. So what I'm going to do is, like, we've gone through that entire process of like going through each instruction one by one. Do you think we're ready to write a bytecode interpreter? Yeah! I like your style. Excellent. So my interpreter.py, we run it, nothing happens. OK. So the first thing I'm going to do is I'm going to start with our code object. So I'm just going to call it, let's actually call it my code object. I'm using Python 3.7, which means I can use data classes, which just make it easier to define a function, or sorry, define a class. So going back to the presentation, we'll need this CO consts and this CO names in our code object. Hold on. So I'm just going to straight up copy paste. Oh, come on. What are you doing? Oh, it didn't copy for some bizarre reason. OK, good. There we go. Sweet. And one other thing is we'll need CO code. CO code you can get from, let's see if I have it here. Cat greet bytecode.txt. That is not what I wanted. Yeah, so I decided, hey, wouldn't it be a great idea if we did some live coding? And then I realized that this is going to be, OK, that's the wrong version of Python. OK. Remember when I said the bytecode, when you use disassembly, it looks like this, but its true form, its final form, actually is this. So let me actually make that a whole lot bigger. This over here, this B, and then in quotes, a whole bunch of gobbledygook, that's the bytecode, right? Some of those are ASCII characters, and those are just interpreted as like numbers between 0 and 255. And the other ones are straight up like 0x1, right? The actual bytes that make up the Python bytecode. OK, so our next thing is def run Python code. It's going to take my code object, which I'm going to call C. And right now, I'm going to just do raise not implemented error. Excellent. So run Python code of my code object. Just want to make sure everything is good. Yeah. Excellent. Not implemented error. So as I said, to make an actual CPython bytecode interpreter, what we need is a value stack. So value stack equals an empty list. What are the, I like already forgot what I need. We need local variables. Excellent. So I'm just going to call it local variables equals this. Another thing that is part of the code object is actually it tells you, and locals is how many local variables you'll have. So in my code over here, I'm going to create a list with c.co and locals. So that just creates a list with that has 3 elements that are all none. So those are going to be my local variables. Cool. The other thing that I glossed over is we need a program counter. That's just going to tell us where in the instruction stream we are. So initially, we're at the first instruction, which means instruction 0. So we're going to do that. And then somewhere in Python, there's a huge infinite loop, right? While true, which all it does is it takes an opcode. So opcode equals co.code at the program counter. So it reads an opcode, and that's 1 byte. And then it reads an argument, and that's at that position. So is, yeah.
All opcodes have 1 argument and 2 bytes?
Excellent observation. So every single opcode has an argument, even if it doesn't make any sense. So I think that's just to simplify the implementation greatly. Yeah, so some,
It certainly simplifies yours.
yeah, exactly. Some arguments are just ignored. We just don't even touch the argument in the instruction. Oh, here? Oh, this is just like my Vim status bar. It's just super, it's just super fancy. All right. So, So at the end of our infinite loop, we're just going to increase our program counter by 2 bytes. All right. And what I'm going to do is I'm going to print the local variables at the bottom and print our stack, our value stack. So I'm just going to say stack and variables.
Is that the same between 2 and 3?
No, actually, it's not even the same between like Python 3.7 beta 1 and 3.7 beta 2.
Okay.
It actually is constantly changing. The nice thing, that brings me to this awesome module called opcode. Opcode actually has a table where you can just like map names to the bytes. So that's from opcode import, I forgot what it's called. Opmap and opname. Okay. From opcode import opmap and opname. Excellent. Oh yeah.
Could you poison the bytecode cache?
Yes, you absolutely can.
How does Python know to refresh or check it? Like if you're on the import, poison it, does it know to regenerate the bytecode?
I don't fully understand how that works exactly. What I do know, okay, so that was a great question. Can you go into the bytecode and just mess around with it, right? Because Python's going to interpret it, it's not going to check if it's changed or anything. Your PyC files, the first 16 bytes state, okay, I am for Python 3.7 version dot whatever, right? It has a little thing that says what Python version is for. Then it has the date at which the source code file was last modified. Then it has the size, what is it? The size of the source code file. It has an alternative mechanism where it can actually hash the source code file, but as far as I can tell, it ignores that by default. So there might be, as long as you don't touch the source code, you might be able to mess around with it. Yeah, that's an excellent point. OK, so what I'm going to do after here is my opcode is, so this opname, I can just use that to take the byte and turn it into like a string of the actual opcode name. So we're going to do opcode, excellent. So now we're going to do if opcode equals like literally anything. So OK, raise not implemented error, opname of opcode. OK, so what I just wrote is that it's going to tell us every time we haven't implemented an opcode. OK. Every time I haven't implemented an opcode, it's just going to crash and tell me, hey, you haven't implemented load const. Remember back to my example? The very first instruction in my instruction stream, so way over here, is load const of 1. So opname, let's actually also print the argument.
What does the 3 dot do again?
Oh, the 3 dots. Yeah, it's just the ellipsis object. I have never practically used it for anything, but apparently in NumPy it like does something. Has anybody used the ellipsis object for anything? OK.
Every time I watch you program, I learn new Python.
Yeah. OK, cool. So opcode load const of 1. It says I don't know how to do load const. Excellent. So if opcode opmap of load const, oops. OK, cool. We're going to start implementing these bytecode, basically these bytecode instructions. So load const, if you remember, what it does is it takes the argument and it uses that as an index into CO consts, right? And that will be our value. And then we're just going to take that value and append it to the value stack. This is really annoying. I'm going to probably get this confused later, but Python calls that method append, but it should be called push, right? So it pushes it onto the value stack, but we call append. Cool. So let's try our interpreter again. So now it says load const 1, our variables are none, but on the stack, we have hello. We've implemented a bytecode instruction. So what's the next one? Store fast. So elif opcode equal opmap of store fast, right? Cool. So that means we're going to take our, that means we're going to pop from our value stack.pop. This one is actually named correctly. And then we're going to, then we're going to go into our local variables, and at our argument, we're just going to put that value. Cool. So let's run the code again. Hey, it turns out our first 4 instructions were both load const and store fast. So we've actually already implemented our first 4 bytecode instructions. So as you can see, it puts a hello on the stack, then it pops it, but it goes into the local variables. I'm actually going to put an extra print over here. OK, yeah. So at the end of our 4 instructions, there's nothing on our stack, but our variables have hello and world. Excellent. So our next unimplemented instruction is load fast. OK. Load fast. OK. So what that does is it goes into our local variables at our argument. That's our value, and we're just going to go into our value stack, and we're going to append that value. Run that again. Excellent. Our stack now contains hello and the space. Now it's saying what we haven't implemented yet is binary add. So once again, just to implement an instruction, it's just adding another condition to this big if-elif tree. So that means we're going to pop, let me think about this. We're going to pop the right-hand side first. Right-hand side is value stack.pop. Then we're going to do left-hand side equals also value stack.pop. And then what our value stack gets is left-hand side plus right-hand side. Does that seem correct?
You need to change the elif.
Sorry?
The elif statement.
Oh, right. OK, thank you. That needs to be binary add. Excellent. Cool. So now, yeah, awesome. So we implemented binary add over here, and you can see that the argument is 0. That argument just gets ignored. It just has to be there. So at the end of that binary add, it's hello space. It does another load fast. It does another binary add. In our stack, we have hello world. Excellent. And it stores it in the variables. The next one is load global. This one's going to be probably one of the more complicated instructions. So elif load global. So you can do, so what I'm going to do is from built-ins. So built-ins are there in Python, just floating out there. But if you want to access it as a dictionary, you can also import it, which is weird. So from built-ins, import the dict, and I'm just going to helpfully call that built-ins. Cool. So first, we need to figure out what the name of our built-in is. So that's going to be name equals c.c of names, and it's going to use the argument. All right, so that's our name. And then our value equals built-ins, which is a dictionary of the name. Is this making sense so far? All right. And then value stack dot append value. All right. So excellent. Yeah. So you can see our stack after implementing load global. Now it's pushed built-in function print onto the stack. And it's also managed to push the argument, hello world. OK, one more tricky opcode to implement. So this one is going to be called call function. So the way this one works is we're going to prepare the arguments for a function call. And we're just going to go for I in range of argument, which is how many arguments to push, or sorry, how many arguments to pop. We're just going to do arguments dot append value stack dot pop. So we're just we're popping values from the value stack and putting it into the arguments we're going to use to call our function. So then our function equals value stack dot pop once again, because that's like the last item on the stack. And then function of arguments. Is everybody familiar with this star arguments notation? No, maybe? OK, yeah? OK. Do you want to explain it?
I use the double star a lot too, but
OK.
it's a syntactical sugar for unpacking.
Yeah.
So basically it takes, if arguments is an iterable, and you put a star in front of it, it unpacks that whole iterable and puts them all as individual arguments.
Yeah, it's as if I like typed every item of arguments in the brackets.
Also build dictionaries and lists this way,
Mm-hmm.
and stuff like that.
It's very powerful.
You put square brackets around a dot argument. It's completely useless. I mean, but you will convert that iterable to a list, or you can just call list on the iterable.
So yes, star arguments is cool and can be abused in horrible ways. Here, I'm just calling the function as if I've manually put in all of the arguments, right? So now value stack.append value. I think that should be all for call function, right? Yes! So do you see it over here? We did it. We printed hello world to the screen, finally. But my interpreter's not done. Our next instruction is pop top. Again, the purpose of pop top is to just get rid of whatever on the stack. What's my implementation going to be? No, it does something. It does something.
Well, you pop the value off the stack.
Exactly, value stack dot pop. And I don't even do anything with it. I just pop it and it gets thrown out. Boom! And then, so pop top worked. The stack is empty. Finally, we get to that implicit return statement. So that loads none onto the stack. And then our return value is also fairly simple. It's just return value stack dot pop. Just whatever is on the stack, pop it. That's what's the return value. So it doesn't look like much, but if I delete all of these print statements, so delete that. Oh, whoops. Delete that, delete that, delete that. Ta-da! We did it! So yeah, hopefully you've learned what bytecode is, how it works, and even how to implement a bytecode interpreter. This has been definitely one of my most ambitious talks ever. Ask me questions.
Is there any practical use to
So, sort of. The practical use of this is that you know how your Python code actually operates in the CPython interpreter, which, remember when I was showing you the difference between load global and load fast? If if you figure, oh, this Python code is not running fast enough, you could look at the disassembly and be like, what instructions is it actually running? And you could either try to use less instructions, or in the case of load global and load fast, use faster instructions. So you'd want to prefer a load fast over a load global. That said, if you're optimizing any code, first thing you have to do is measure, figure out what part is slow, and then second, these tiny micro optimizations, only if they're in a very, very tight loop do they matter. Usually you have a different problem. Maybe your algorithm could be improved, or maybe you could use a different data structure, that kind of stuff. That stuff you're probably going to want to optimize before you get into the little nitty-gritty bytecode stuff. Yeah?
Is there any advantage in saving print to it? Let's say you were doing print a lot, or
Yeah.
some other built-in.
Yeah.
Saving that built into a local variable, and then calling your local variable constantly in order to prevent it from having to load global every time.
Yes, exactly. So is there any advantage to taking print and putting it into a local variable? Yes, it's faster. You can print faster, except not really, because printing is slow to begin with, compared to the speed of loading loading variables.
So is this interpreter that you wrote
Yeah.
Faster than just doing the print hello world? Or is it?
No, it is orders of magnitude slower than print hello world. It is very slow. I just wanted to show you that it can be done, right? And it can be done in a very nerve-wracking live coding session. So yeah, maybe not for print, but so if you look at the JSON module, json.py, its code is really, really disgusting and gross because they're taking int and they're taking object and all of these built-ins. So int gets called a lot and float gets called a lot, and in very, very tight loops. So in that case, they do store, they say, float underscore equals float, and then they call float underscore. Because it's a local variable, it loads faster, and it actually does have a real performance impact. Yes? More questions? Yeah?
If the argument's only 1 byte, does that mean you can only have 256 variables per function?
No! There is an opcode called extended arg, which just you can load more arguments 1 byte at a time.
Okay.
Typically if you have more than 256 local variables, what are you doing? Stop it! Yeah, totally. You're writing a Python interpreter. That makes sense. So extended arg doesn't get used too often, but it does exist. So that limit doesn't exist. You can have more than 256 arguments. Yeah?
I have 2 kinds.
Yeah?
The PYO file.
The PYO file is an old Python 2.7 thing. There's a certain set of optimizations you can do. And then the PYO is just the code object, but with those optimizations enabled. I forgot what they were because they didn't seem very useful. I think one of them deletes assert statements, which is not an optimization. Keep your assert statements. I forget the other optimizations, but basically, and it deletes, right, it deletes the documentation comments. No, keep those too. So basically, I don't ever run Python optimized. So there is, where am I? In Python, there is something called the peephole optimizer. And that actually does run by default every time. And it goes into little tiny sections of bytecode. And it tries to make those small sections of bytecode faster. It uses less bytecodes or something like that. So already there's an optimization step in compilation by default. Yeah, you had another question?
Yeah, I want to go back to the screen where you just originally showed all bytecode.
OK,
Yeah.
sure. This one? Or the less complicated one? This one with this dude?
Or before that.
Before that? Oh, this stuff!
Yeah, that's
Yeah! Excellent. Okay. What do we want to know?
No, I just wanted to look at it again.
Okay.
Yeah.
Yeah.
Just take it in.
Yeah.
Yeah.
It's a work of art.
Yeah. So I can actually sort of explain what's going on here a little bit, which is scary. The very first line is the header. And that just contains, again, this is for Python 3.7, beta 5. And then the last part of that line has the last modification time. And then the rest of it is actually 2 code object files. So we've been looking at the code object for the function greet. But this is a module, right? A PyC file is created for module. So what other code object is there here? Yeah, the greetings module itself has a code object. So if you go over here, examples, and if you do, another way to use the dis module is if you do Python 3-m. Has anybody used Python-m? OK, so Python-m, you can run a built-in module with Python-m as if it's a script. So you can run the dis module as a script and do disassembly of greetings.py. So you'll see, in addition to the code object we've been looking at the entire night, there's also this other smaller code object. And the first instruction is load const of another code object, then the name greet, the string greet, and then make function. That's how modules work. And this is actually what runs whenever you import a module. Yeah?
The M flag, did you say that's only for built-ins?
I said it was only for built-ins, but that's a lie. It's for any module.
Okay.
Yeah, so dis and whatever other modules you have.
Actually implements function.
That actually implements main, because not all of them do.
Because I believe you have to have that if name equals name section at the bottom. And so for a lot of them, if you do that, it'll just return none.
Yeah.
Because they don't actually have a protected script. It's like you took your module and tried to run it as a script. It would run and then return none and you're done.
There's like a few weird ones, like Python import anti-gravity gives you this
Yeah.
XKCD comic. Or has anybody did import this? Yeah, import this is like gives you like, I guess, a poem.
There's one from future import brackets.
Oh, right. Oh, but I have to do that. I can't do that from -m, but yeah. That one's good to show. Python 3 from future import brackets. Who wants brackets in their Python code, like curly braces everywhere? Syntax error. Oh, what? Did I do this wrong?
Is it still double? Is it still double?
Or is it just bracket? I don't know.
Oh, maybe they deleted the joke. Maybe it's only in Python 2. I know it definitely exists. No! OK, I forgot what it is. Huh? Braces. OK, from future import braces. Syntax error. Not a chance. It's not happening.
Which Python are you in?
That was 2.7. I just typed it wrong in Python 3. Let's see if it still works in Python 3. Yeah, OK, it still works. Yeah.
All right, well, thank you, Eddie.
Yeah.
Recently, I got really into board games. I have a really weird personality where if I'm interested in something, I like to learn it a lot. So I started playing board games with my old crew that I worked with. And yeah, it was a lot of fun. So playing board games and going to a board game cafe, the natural progression is to just start buying board games. So I went out and now I have considerable amount of money sunk into board games. The problem is I have to like make things my own. So I bought a bunch of board games. One of the board games that I bought is Bang. Anybody ever play Bang? Yeah, so a few people. You're basically a sheriff or an outlaw or a renegade or somebody like that, and from the old out west. And you have to find out who everybody else is, and everybody knows who the sheriff is, right? And then you have to shoot each other and kill each other, and based on whoever's left over, wins, right?
Kind of like Werewolf.
Yeah, kind of like Werewolf. So for that game, I'm like, oh, I have to make it my own. So I bought a little tin star badge and have a little magnet behind it so you can wear it while you're the sheriff, right? I bought a game called Kitchen Rush, and now I have a bunch of chef hats that are in the box that when you're playing, you can put on a chef hat. And I bought a game called Betrayal at House on the Hill, which is a pretty fun game, but the rule books for it, the little magazines, are quite shit. So
I'm gonna have to censor that.
So, like, you play this game and you're playing and you're building tiles and you're building a room and you're building this mansion and everybody's going throughout this mansion exploring things, getting items, leveling up. And at one point in the game, there's this event that happens that one of you becomes a traitor.
Spoiler.
Yeah. So the great thing is you look up in this book and based on like the item that they got and how many people are there and whatever, it tells you what the twist is, right? Who's the traitor and what their secret objective is, right? So you give them one book, the traitor, and you take the other book, right? And it's not always the same person as the traitor. Sometimes it's the person who found the item, sometimes it's the person to the left or the highest strength or the highest whatever, right? Or maybe there is no traitor and you all have to like do something together, right? Like Scooby-Doo. But you have to go off and read this traitorous tomb and then decipher what it is. And then the other team has to go and read the Secrets of Survival little booklet, and it tells you what your objective is. And the great thing is if you haven't played that scenario before, you don't know what the traitor's objective is, and you only know what your objective is. So it's kind of like this, nobody knows how they're going to win or how the other person will win. You just know how you are going to win, right? So you can kind of like play off of that, right? I bought the expansion for it, so there's now an additional book. So first one has 50 scenarios. The expansion has 50 scenarios. That's a lot of scenarios. That's a lot of books that you have to carry around and look up and keep with you. So instead, I decided, hey, I'm going to make a hardcover book and take this Traitor's Tomb and make it into a hardcover Traitor's Tomb, make it look a little like scary with like maybe like a cloth finish on the front or something like that. I won't do it myself because I'm lazy. I'll probably get a book making place to do it. I don't know yet. But I do need to take that book and convert it into text so that I can format it nicely so that I can print it, right? So this sounds like a lot of typing. If you don't know me, I'm exceptionally lazy, so I don't like typing. I don't like typing for code. I don't like typing at all. I bought a nice keyboard. I don't like using it. So I decided, hey, why don't I take a picture of every single scenario and then use Python to convert it into text? So that's what I'll be showing you today. So a little bit about that. We're going to be using a library called Tesseract, which is an open source AI for converting text into, well, converting images into text. It's actually really, really easy to use. And the majority of the work that's going to be going on is just cleaning up the image for processing. So first approach is get the images into like a digital format. So take a picture of them. So I use my phone. I'm going to disconnect my laptop right now. So what I'm going to do is I'm going to use PhotoScan by Google in order to take a picture of something, right? So all I do is take some text, put it on a nice surface that's a different color than it, and then I put it up. It's a better demo if everybody can see it, but you have to trust me. I hit the button, it looks at it, I move it around a little bit because it tells me to. And then it does some magic. I don't really care or know what it does because I'm a programmer. And I program horribly, and Google's a lot better than me. And I'm fine at admitting that. So now I have the image on my phone scanned in, it cropped, it actually square and looking great. The glare somewhat reduced. So then I'll just take that and email it to myself because everything else is very, very difficult to use. So I email, and then I'll bring it up. So what I've done is I've taken a bunch of photos of the book. Maybe I shouldn't have unplugged it, no? There we go. Yay! All right, so I've taken a bunch of photos of the book. You can see that's the outcome of taking a photo of a book. So gives you the haunt number and what you have to do. This one's a kind of a long one, so it's on 2 pages, but the other ones are quite a bit smaller, right? So, and this is from, I don't know, Secrets of Survival, I believe. That's the good guy's tomb, right? Instead of the traitor's tomb. So I've taken that and I wrote a little bit of Python, not a whole lot. It's really simple, it's really, really ugly, and it's only for me. I won't release this publicly because it has no tests, right? So if you want a copy of this, no.
Or write the test.
Yeah, you can write the tests and then I'll give it to you. So I wrote 2 commands, one for cleaning and one for putting the image to a text. Cleaning, what are we going to do? We're just going to take the image. We're going to make a nice little argument parser so that we can parse the command lines. What do I want? I just want a folder with images, and then I want another folder that has the images that are all cleaned, right? Makes sense? Everybody, yeah, perfect. So I'm going to specify I and O, input, output. And then it's going to just grab all of the images that are in the folder. I can definitely zoom. Just going to grab all the images that are in the folder, right? Sort, grab them, put it into a list. Get some time because it took a lot of time to do this image processing, so I want to capture that. And then just clean up the image, right? So my clean image function is up here. Just read it with OpenCV. So has anybody here used OpenCV? It's a fantastic library. So if you're working with images and stuff like that, OpenCV, great. Yeah, it's super easy to use. You just open up the file, and then you can do like really complex things that I don't understand to clean up files. So I don't know what most of these things do, but I don't have to, because since I'm putting it out to a file, to another file, right? I can just run a bunch of stuff that I find on the internet and say, hey, did this clean this up or not, right? So I can apply dithering, which is just removing some noise and stuff like that. And then I'm going to run it through a bunch of filters in order to try and filter just the text, because I want to remove the background, right? So I have 7 different filters that I want to test to see how they perform, right? So we'll run through every single one of them using this for loop, and then just calling them, and then appending the method to the file name. So if this is for haunt1, I've named the original image file 1.jpg. I think it's a JPEG. It's a file. It's an image file. So it'll be now 1 underscore and then the method that I've used to clean up the image, right? So 1, 2, 3, 4, 5, 6, 7. Don't know what they do, but hey, we'll run it. Find out what happens, right? So I hate typing, so I'll go into my workspace.
Can we get bigger?
Yes.
Just the window, not the text.
Control plus plus.
I think it's just Control+. Do you have to hit the shift button?
Ah, shift. All right, smarter than me.
It's one of those pluses.
Yeah. So I hate typing, so let's just make a quick makefile. So that's my makefile. Don't judge it. They're all judging it. So all I have to do is just type make, and it's just going to run my clean.py input to the originals images and output to images/cleaned, which is a great name. First, I'll activate my pip environment, pipenv shell. All right, so I'm in my pipenv shell. I will show you the images beforehand. So the originals. So these are the images before. They're fantastic. They're great. It's like I went on a vacation, and you're all my family. And you're all jealous. There's me in Cancun. Here I am on a beach. No? All right. So yeah, they're in varying degrees, different colors. We want them in black and white. Old school. So instead of applying an Instagram filter, we'll just use this. So make. So it's going to go throughout them and start just doing them. I don't care how long this takes. I've got all the time in the world because I have to go and take photos of the other book. So that's the thing that takes the most time. But we can go in and look at the cleaned images. So they're just generating right now. You can see them slowly populate. It's a very old laptop. It's aged well, like milk. So we can go into it, and here, let's look at number 13, lucky 13. So we can look at, or you know what, we can look at number 8. Okay, 13. So this is number 13, method 1. Not bad, right? Method 2. Did anybody see the change? No? Method 3, nobody see the change? Anybody see the change? Kind of, yes. This guy. Yeah. 4. No. 5. 6. People see a change? Yeah. 7. Yeah. Quite a bit different. All right. So this taught me that it doesn't actually matter. Just use number 1. So. So let's just do that, because that's going to be a lot less of a headache. So we'll just comment that out. We can add dithering and stuff. It actually doesn't help that much, so let's just not. I could show you if you want. Nope, nobody cares. Okay, good. Yeah.
That's what the make file's for. You could just end it there.
There. It's good. It's perfect. Remember, I'm not giving this out to the wild, right? So
Don't code like this.
yeah, if you're doing this at your job, find a new job. So yeah, we can just, let's terminate this, because this is going to take forever. It's an old computer. So, make. That's just going to, image. Oh no. Where did I mess up? Anybody can see it? Dot, where? Oh.
It's a comma
Oh.
at the end of your print statement.
Wait, what? What are we doing?
That's good.
We're good. All right, let's run that. All right, so it goes through them. It's a lot faster, not doing 7 different image cleanups on each image. Maybe. So there's the images, and now we're only just naming them 1, because like, why not? Why am I telling you what the method is? Because we're only using the 1 method. So yeah, that's number 1. That's number 2. That's number 3. Looks pretty good. We're getting there, right? So the next hard part is taking this image and converting it into text, right? So let's look at that. Image to text. So we've got this we've got this fantastic main here that's just a copy and paste of the other one. So nothing too much to see, and input and output. I want the cleaned images as my input, and I want to output text files, right? And then I'm just going to add them to a list, find all the image files there, add them to a list, print the image file name so I can see it, and then read the image and output it as text. So my convert an image to a text is basically 2 lines of Python, one to read the image into OpenCV, and the other one just to call PyTesseract, and that's it. I don't have to do anything else. So Python's quite easy, quite simple to use. That's the one magic line. I don't have to know what it does. I don't really care. Google has done the hard work for me. Let's go see the results. Text, and here's the text. Number 2. So this should line up to a blank file. No. So that should line up to approximately what this is, right? So I can take that, throw it on a different screen, go over here, grab that, put that over here. So that is kind of like that. I'm still going to have to read through it, add in a few things. This A doesn't come through, so the first character of the thing doesn't come through. So there you go. And that's it. So a lot less typing. I do have to proofread it. However, I can use Mechanical Turk for that. So might be a next talk.
Google did all the work, but really we did like back in the early 2000s filling out all the captions.
Yeah. If it wasn't that successful with reading this, then I could have easily just another line of Python, put in a bunch of images that are like this, and put in a bunch of text, and Tesseract will go in and say, oh, this should match this, let's learn on it, and it just learns it. So it's really super simple and easy. I don't need to know it, I don't need to be smart, but I used it. So yeah, that's it. Now I'm just going to take them, concatenate them together, turn into a latex file, and then send it to a publisher. So that's it.
Spend about a year reformatting it.
Yeah. All right. So yeah, anybody have any questions? Super simple, easy. Everybody wants to do it? Yes. I won't sell copies. However, I will give you all of the text online. I don't know if I can do that. I will secretly bootleg it to anybody who wants it, right? So I am a captain. I've taken my pleasure craft test, so I do have I think it's in my wallet, actually. Yes, I am a captain, a pleasure craft operator. So, Captain Pirate. So if anybody wants that, you can have it. Anybody else? No? Yeah.
I got a question. So for the size of font, is either we like adjust in the export where that we can just make sure that the size of the font will be exactly the same as in the page.
Pardon?
The size of the word.
Oh, the size of the words. So like taking the font?
Yeah.
So that's a problem for LaTeX. So all I'm going to do is I'm just going to take that text, throw it into LaTeX, which is just a text formatting tool, kind of like Microsoft Word, except it's on steroids, so it works like really, really well. And then it will be able to resize the text for me as much as I want, and it can do page breaks and everything for me very, very nicely. So.
Do you know if Tesseract can give you rich formatted text? Because that's just plain text.
Yeah, so Tesseract doesn't.
Doesn't, okay.
But I can easily just grep pipe, cat star pipe, and then pipe it to a file, and then just take all those files and import them into latex.
Yeah, that would work.
Yeah. So, yes.
Does Tesseract work with handwriting?
With handwriting, very poorly. But if you train it, yes, it does. And I know that there are some financial institutions that are looking to use Tesseract in order to read check data. They do it very, very poorly. But yeah, if you're looking to use handwriting data, I would suggest AWS has an image recognition service, and so does Google Cloud Platform. So just use them, save you some grief, a lot of grief, tons of grief, no grief. Yeah. Anybody else? All right. So that's the end of the Python meetup. Feel free to stick around and chat and talk. If you want more information about the job with Leventon, come talk to me. If you want more job about the thing at Helm, talk to this guy. All right. Thank you very much for coming out.